All right, Java performance concept. So here we're going to talk about a few general concepts, performance matrix, and the concept of monitoring and profiling. And then we're going to go through general development process, meaning how we're going to actually perform performance testing. Before we get started, so just the general concept on performance tuning. Performance tuning is largely an art, which means there is no single approach that applies to every single application performance testing. Okay, so keep in mind that not every change made to improve the performance will work for every customer environment. Okay, so there are certain set of performance the guidelines, but not all of those will be actually applied equally to every application you are doing performance testing. Key point, performance testing must be integrated into entire product lifecycle to ensure continuous product quality, which includes the phases include development, build, and release and maintenance. All these phases should include performance testing as one of the key components. Let's talk about the performance matrix. So performance testing determines or validates quality characteristics of the product under test, and these quality characteristics include response time, throughput, resource utilization, scalability, and stability. Key types of performance testing. So when you perform performance testing, you could actually categorize them into these four different types. Performance tests, usually we are talking about the speed of response time. And then you do load test and stress test. So load test is to verify application behaves under normal and peak load conditions. Stress testing is to make sure the application behavior still is within the performance guideline, even when the performance, the workload is beyond the normal, normal workload. Okay. A capacity test is to determine how many users or transactions a given system can support and still meet performance goals or guidelines. Performance matrix includes throughput, runtime response time, and memory footprint, and CPU resources, and also there is a perceived performance, and this is typically for GUI applications. Let's talk about the performance, the perceived performance of it. So it basically is basically related to end user experience on GUI applications. So it measures how fast something feels from user's perspective, not actually how fast it actually is. So in general, response time of 100 milliseconds or less is perceived by the user as normal. Okay, it might not be as fast, but it might be normal. Okay, and so anything over that could be actually considered not functioning properly. Ways to improve how fast your users feel without actually making anything run faster. So basically, you are actually giving some indication to the user that so that to indicate to the user that something is going on. Okay, so basically changing the mouse cursor to the awaiting cursor. And using multiple background threads and displaying a status queue for long-running tasks, and showing a progress bar for relatively short tasks, and when enumerating larger sets of data, always provide a filtering mechanism. So these are the things you can use to give some indication to a user that something is going on. Okay, so it basically improves the perceived performance. The startup time. So lazy initialization is often useful. Okay, so meaning you display something and then you do the initialization while things are being displayed to the user, so user can actually see something. So various types of application will use different ways of actually improving the startup time. So applets use jar files to minimize requests, meaning you are going to actually include everything into jar files. And sorry about that. And install on client system if possible. If you have any the libraries, you want to actually install the client system. Of course, this is the case that you have some control to the system. Okay, And you can use obfuscators to reduce the size of the files. For standalone Java applications, you can use a separate initialization thread and minimize the dependencies for start screen. And for web application, there are a lot of the schemes you can use. Basically you want to minimize the number of server communication from the browser, and you want to minimize the size of the files as well. Let's move on to monitoring and profiling concept. So the definition of performance monitoring as opposed to performance profiling is actually an act of non-intrusive collecting or observing performance data from an operating or running application. Okay? So this performance monitoring is typically for preventive or proactive type of action, but it could be used for reactive action as well, meaning once you got a problem, then you can actually start the performance monitoring. Can be performed in production or qualification or development environments. You can use performance monitoring in all the types of the environment. And it helps identify or isolate potential issues without having a severe impact on runtime responsiveness or throughput. So performance monitoring is actually considered non-intrusive or less intrusive than performance profiling, which we are going to see in the next slide. Okay. Oftentimes, monitoring crosses over the troubleshooting or serviceability. So typically, you might want to use the performance monitoring and performance profiling in kind of sequence or in combination. Okay, performance profiling. So this is an act of collecting or observing performance data from operating or running applications. And performance profiling is considered to be more intrusive than performance monitoring. And because of that reason, you might want to perform performance profiling on a narrow focus, meaning you want to actually performance profile on a smaller segment of your code. Typically a reactive type of activity. So when you have a problem, performance problem, then you are going to use a performance profiler to, to find out what is going on underneath. Okay? Performance profiling, because it's intrusive, it seldom is used in production environment. And so this performance profiling is typically used in qualification or testing or development environment. Performance tuning, so it's act of changing tunable. So you might want to change the source code, and you might want to change some configurations of the system for the purpose of improving application responsiveness or application throughput, so basically improving performance, and usually results in from monitoring and profiling activities. Okay. By the way, in this code camp, we are going to mostly focus on performance, the aspects from a Java developer standpoint. So we are not going to actually get into a lot of system admin type of performance tuning. So mostly we are going to actually take a look at the Java developers, what we can do as a Java developers in terms of improving performance, except the last topic, which is the web performance, in which we are going to actually cover the some of the JavaScript and CSS and things like that. All right, so let's move on to development process. So this is the typical development process. Okay, start and you analysis, you perform analysis, and you design code and test and quality, and okay, so it's pretty general. Now you're going to actually add some profiling as part of your development process. Okay, so and then once you have the desired performance, and then you're going to actually start monitor to make sure the application is performing as expected, even in production environment. So performance testing activities, you can actually have the sequence of steps. I mean, this is not really, the casting in concrete. I mean, you might want to actually follow these steps in general, but not always actually in exact steps. Identify test environment, and then you might want to identify performance acceptance criteria, and then you're going to plan and design test. Then you configure test environment, and then you implement test design, and then you execute the test, and finally you are going to analyze the result. So let's take a look at each of these steps in a bit more detail. So identify test environment. Okay, so you identify physical test environment and the production environment as well, and then you also want to actually, think about the tools and resources available to the test team. And of course, the physical environment includes hardware, software, network configurations. And of course, this is pretty kind of obvious. Having thorough understanding of the entire test environment at the outset, in the beginning of your project, enables more efficient test design and planning and helps you identify testing challenges early in the project. So what it means is that testing should be as part of your project, the life cycle from the beginning. In some situations, this process must be revisited periodically throughout the project life cycle. Okay, so maybe depending on the situations, you might want to change your test environment, okay, which is kind of obvious as well. And then you identify performance acceptance criteria. So basically, again, you want to actually come up with the acceptance criteria, which involve the response time, throughput, and resource utilization, and the other aspects. Usually, a response time is a user concern, and throughput is a business concern, and resource utilization is a system concern. So the stakeholders might be actually different, and then you want to include all these stakeholders into your project from a testing perspective. Additionally, identify project success criteria that may not be captured by these goals and constraints. So, for example, you might want to actually record what combinations of configuration settings will result the most desirable performance characteristics. So these kind of information could be actually useful in your project. Plan and design test. So again, identify key scenarios and determine variability among representative users, meaning stakeholders, and how to simulate the variability and define test data and establish matrix to be collected. Okay. So, the key point is that planning and design phase, actually, you want to actually document all these aspects so that you can actually later on analyze based on this criteria. Consolidate this information into one or more models and system usage to be implemented, executed, and analyzed. Yeah, this is kind of obvious as well. Now, the last key point is actually kind of important. The subset of the most important scenarios. So, the testing scenarios should be identified and incorporated into build process for continuous reporting throughout the product life cycle. So, performance data should be collected as part of the continuous development and continuous deployment tools such as the Jenkins, so that you can stakeholders can actually figure out what is going on. Okay. So performance trend is again very important things that you want to capture as part of your life cycle, the project life cycle. And then you configure test environment. So basically tools, resources, and you want to actually, so prepare test environment tools and resources to execute each strategy as features and components become available for test. Yeah, so again, ensure the test environment is instrumented for resource monitoring as necessary. And then you implement a test design, and then you execute the test. Okay. Now, key point of execution of the test that the result must be repeatable and consistent in order for the testing to be considered valid. Okay. Execute validated test for analysis while monitoring the test and test environment. And finally, you are going to analyze results and report and retest. All right, so this is pretty much a general guideline. Okay, so let's just move forward to